Awesome. So, sorry I missed you Thursday. Good meeting with the surgeon. Of course, he took all of 5 minutes with me, like doctors tend to do for a full appointment, but sure. He said, do things that don't hurt. Everything looks good, so it's good to hear. And I'm starting to feel better, so working on getting caught back up. This week, we've got arrays and vectors. You should have already done all of this last time. We're going to hit it again, and then I'm going to focus on two-dimensional arrays and vectors because I think they're much more interesting, right, with rows and columns. They're not actually in rows and columns, but that's a nice way for us to visualize things. Otherwise, it starts to hurt our head. And then if we're feeling like we want to have even more fun, and maybe on Thursday, we'll get into three-dimensional vectors and arrays where you have rows and columns and height, right? These sorts of things get to be a lot of fun. You can go 4 and 5 and 6 and 7 and n-dimensional, and I don't even understand it after 3. Like fourth dimension, I can't do it. You can if you want, and if you get it, great, more power to you. At that point, there's got to be something better we can do, and a little easier to do, because having to track 4 dimensions is just crazy. But that's okay. So this is all from chapter 9 of Zybooks here, the arrays and vectors bit. So I'm going to assume you know a lot about them. Is that fair to assume, or do you know nothing about them?
Vectors and lists?
Yeah, vectors and arrays.
Kind of in the middle for me.
Okay, in the middle? All right, good. So week 4, arrays and vectors. Now, I probably should apologize. I think arrays are really obnoxious, and you can shoot yourself in the foot with them, and I just don't use them. So everything I do will be with a vector because they're better. They're technically ever so slightly slower because there's additional stuff that has to happen behind the scenes for vectors to actually work here. So, sure. But for our purposes, this difference in speed does not matter, right? We are not going to do anything anywhere near the scale where the speed's going to matter for us. So it doesn't matter. We'll do our namespace, standard, and great. So we're going to include.
I got a question.
Yeah.
How big of a change in speed is it if you have a big program versus if you have a smaller program?
If you're doing something 1 million or 1 billion times, it matters. If you're doing it 100,000 times, no one cares. Right? That's sort of so. It's got to be a really large amount of operations for it to really matter. They're not very much different here. Because it's a class in the library, it has to do a few extra things every now and then. That's all. So we're going to include vector here. Now, we worked with dynamic arrays and dynamic memory, and that was lots of fun. And it was nice that it didn't have to be a constant static compile time value. That was nice. Vectors didn't have to be that anyway, right? We could push back to vectors. We could just expand them as we wanted. That's the nice big benefit. They don't have to be stuck at a specific size here, and that's why we really like vectors. So let's go ahead and see if we can have a little bit of fun with our vectors here. So I think what I want to do is make this into a class. So I'm going to make a class that lets us play tic-tac-toe. That sound like fun? And then we'll track the tic-tac-toe board as a vector. So we'll go make a class for it. So we'll go add a header file. Again, I feel bad every time putting all of my code in header files. It's technically bad, but I'm just lazy, right? Don't shoot me. It'll be fine. If someone tells you you have to do implementations in your CPP file, just smile and nod. It's not that much harder to put them in there. It's just one extra step that I don't want to do, and then it makes testing harder for me. So is that okay? We'll call this tic-tac-toe here. So we need to do, using our namespace standard, we need to include vector, and then we'll have our class tic-tac-toe. We'll have a private section, and we'll have, private section, and we'll have a public section. So private section for tic-tac-toe needs to be the board, right? So I need to track all 9 spaces of this tic-tac-toe board. Again, I like vectors. We could use an array, but I like vectors here. So I'm going to make a vector of type char, right? So vector of vectors of characters. That's my 2 dimensions here, right? So I'll have individual, each row here, and then I'll have the rows stacked up in their own vector. We'll draw a picture in a second here. So here's the board. So that's our private board here. Now, what do we want to do with this? Well, when I create an instance of tic-tac-toe, I want to make sure I have a board, and it should be empty here. So we don't need any arguments for it here, but we need a constructor that can go and give values to all of our attributes. The constructor's job is to give values to your attributes, right? How do you create the instance? Give it something meaningful, some good values here. So we'll make our board then, and we're going to push back a vector of type char here. And we want to do that 3 times, but each one of these, we really want to add 3 empty spaces to it, like 3 empty characters. So maybe we actually wait on that one for a second here. Maybe we'll make our row, so our vector of type char, called the row. And now you can initialize these, which is nice with the initializer. So you don't have to go and push back 3 different times. Have you seen the vector initializer? You just give it your initial values, right? Okay, so I went and added a row, and then I'm going to go add that row to my board, which is a vector of chars. Right? Now that I have the vector of char, I can push that back onto the board. Right? And we'll do this 3 times, right? So for, I don't know, int row number 0, row number is less than 3, row number plus plus. We'll go make that, and then we'll push it back. We'll take my board and we'll push back the row. Right? So make a vector of char, 3 empty spaces, and then add that to the vector of chars, right? Because that's what this one can store. Right? Row fits the type that the outer vector is. Its type here is the vector of char. Right? Okay, so now we've got an empty board. So we probably want a way to print the board or return the board as a string. I generally like returning things as strings from classes because not every program you're going to write, thankfully, is going to use cin and cout. Right? Most of the time, we're not going to be doing stuff with the console input and output in the real world. There are some cases we do, and it's fantastic. But rarely do you folks ever use a program that opens up the black box in terminal and says, please type stuff in, right? That just doesn't happen for most people, right? So if a class is tied to outputting stuff to the standard output, it's not portable. And that's one of those dreams of object-oriented programming, is our code is reusable. It's portable. I can take this amazing class I wrote and use it in a console application, or I can use it in a graphical user interface application. I can use it in a web application. I can use it in a mobile application. I could do whatever I want with it. But if you're tied to the standard output, you can't, right? So that's why we like representing things as strings. So we'll make a function that returns a type string. Oh goodness, I have to include string. Include string, there we go. What do we want to call this? Like display or something? I don't know. It's probably okay? That's fine. So we need to build the string then for the result. Then it's going to start off as a nothing to start, and we need to start going and adding all of the pieces to it here. So, and I want to make it look pretty, right? Because we like when things look pretty. So the tic-tac-toe board should be nicely divided, right? With our lines down between the columns and the lines between the rows here. So we should be able to make that work. So we want to take our result, and then we want to add to it here, right? Just append to it my board at row 0, right? At column 0. So give me the first row here, and then give me the first item in that row, the column 0, right? So we think of this as row, and then we think of this as column. It's not exactly like that, but it works out visualizing it pretty nicely. If we stack them up, we put a vector on top of a vector on top of a vector. We get rows and we get columns, right? So we get that one, and then we get a character, right, of maybe the pipe divider here, and then we want to append in the next one here, board at 0, and then column 1, and then append in a pipe again, and then append in board at 2. Still row 0 at 2, right? That works out nice, right? And then I want to do it again, right? But now I need to add that divider row, right? Add my dashes across. I'll take my result plus equals, and it's just a bunch of dashes, right? So first one, second one, third, fourth, fifth. Is it 5? 1, 2, 3, 4, 5. I think it's 5 characters here. We'll add that one in. Oh, but we forgot our new line, right? We also need the new line character plus, oh my goodness, plus an endl? Can I add an end line? No. Okay, we got to add the \n character here, right? Add our own new line character right, instead of an end line. I think that'll add in better for us here. We'll add that one in plus an end line here, and then we'll repeat again here. So, but now we want row index 1, right? Give me the second row, index 1, because we always start counting by 0. index 1, another one of these, and then I want the third row here, which is index 2, and index 2. So we have basically the same code a bunch of times. I feel a little bad about it here. We could use a loop. Sure. I don't know if it's actually saving any time to add a loop here versus a little bit of copy paste. It's probably okay, right? And then when we're done, we're going to return that result. Okay. Not the most efficient. That's okay. Don't sweat it here. It's, you know, what is it? 5 times 5. It's 25 characters that we put together in a string. It's probably okay. So you want to make our board and print it, right? Other things that we want to do with the tic-tac-toe board then are you should be able to mark the board. We probably also need to know whose turn it is, right? Because whoever's turn it is the one who's marking. So when we start here, we probably need a char for current player. And well, usually X's go first, right? So you can technically initialize things in your declarations here. That's really ugly in bad form, so don't do it, right? Put all of your initial values in the constructor. That's the constructor's job, right? You know, assigning here to X is probably okay, but again, it's just really ugly in bad form, so don't do it, right? So to say, hey, my current player equals X, right? Current player is X. We'll always start with X, right? And then we have some sort of method, probably a void method, right? To mark the board, we'll say mark board. That probably needs to know what row and column they're marking, right? I don't know how someone else will get this input. I know for our purposes, we're going to use console-based input. We'll ask the user for the row and the column, but a graphical user interface might do something else. A web application might do something else. Your mobile app might do something else, right? But what our class needs to know is what row and column, right? So you tell me the int row index, and you tell me the int column index. So if you tell me those two things, I'll go mark the board for you, right? But I need to make sure it's valid, right? You can't put a mark on top of someone else's mark. So we can check. We can say, hey, if my board at the row index, at the column index, does not equal an empty space, then we've got problems here. Then we can throw, I don't know, argument exception or something. What was it? Error exception. What do we use here? Invalid. Isn't it invalid argument? Why can I not remember what we just did? We just did this. What were we using? You guys forgot to? Okay, don't feel as bad then. I'll just go look. What do we do here?
Don't you gotta put in a try-catch block?
Not in our class, right? Our class should throw, and then it's up to whoever's using it to go and deal with it here. That's the exceptions and pointers. Where was it here? Is it just a header file? Oh my goodness. Lowercase invalid argument. Oh my goodness. Sure. Okay. Lowercase invalid argument. Oh, we didn't. That's right. We didn't include it here. So we got to include a standard exception or something. Standard exceptions. There we go. Now we'll get their invalid argument. Okay. I remembered. No, I didn't look it back up. That's fine. So throw an invalid argument here. Location. Or I don't know. Space not empty or something. Right. That's no good here. If it's not empty, tell them it's not empty. The other thing we should probably check for is to make sure these indexes are valid. But our vector kind of does that for us, right? If you try and get at a bad vector location, it yells at you automatically. It'll still throw an exception, it just won't be from our class, it'll be from vector. That's probably okay. If you wanted to be fancy, we can make it check here, so the exception comes from our class. It's perfectly fine. It's still getting checked, right? Because you can't give a vector an invalid index, right? It'll yell at you here, which is nice. So maybe we'll add a little note. Vector checks for valid index. We'll throw. Okay, so if we didn't throw, now a lot of people here put the else because they started an if block. It's redundant. You don't need to at that point here, right? Because if you throw, your code stops. Game over. It doesn't get any farther here. So the else is redundant. Save yourself 2 lines of code, 3 lines of code, a little bit of typing here, and just don't bother, right? So we'll say, hey, my board at the row index, at the column index, column index is equal to the current player. Right? Put the current player's mark in that location. Right? Now we need to change current player. Okay? Most everybody does it this way. We say, hey, if current player is equal to X, then current player equals O, else current player equals X. Right? This is how almost all of you would write this, right? Is that a pretty fair assumption? Okay, you know how I know when people cheat? When they write this garbage, they say current player equals X if current player equals O, otherwise otherwise X or something. No, otherwise O, right? If you write this, I'm like 99% sure you didn't do it yourself and you got it online from ChatGPT or someone else online, right? ChatGPT loves these awful ternary expressions, loves them. I hate them because it's super confusing. Like, what is happening here? If you've done it enough here and you've been programming for lots of years and you're familiar with them, you're like, oh, okay, right? This is like my if block. If it's true, I get the thing on the left, otherwise I get the thing on the right. Who comes up with this stupid syntax? I hate it. I just hate it, right? I would much rather spend the time typing this out here than a ternary. But again, you know, style preference, sure. You could feel good that you used 1 line of code instead of 6, but, you know, sure, good job, you're fancy. I don't know. I would much rather have more readable code than something I have to spend 30 seconds looking at and trying to remember which one comes first. That's all, right? Should we leave it because we're fancy? We can leave it because we're fancy. That was control slash, by the way, to comment and uncomment. If you grab a bunch of lines of code, your control slash shortcut will comment it all for you, right? This gets a lot here. That's okay, just for fun. So after the player goes, move to the next player, right? We probably need a way for the game to tell the player, the person using the game class, our tic-tac-toe class, whose turn is it, right? So a char for, I don't know, whose turn is it? Who? Who's? Is there an apostrophe there? We can't put apostrophes in it. It just looks really weird. I don't know. We'll just say get current player. How about that? Get current player. That sounds much more programmatic anyway, right? As a get function here. So we'll just return current player. Look at that. Hey, it's X's turn. It's O's turn. Sure, right? You mark the board, we change the player. Mark the board, we change the player. Display the results. Now, we don't have a way to know if the game is over or not yet. That's the next thing we need to do. We have to figure out, is the game over? And that's probably a public function, right? Our class should take care of that itself. That should be one of the details that our class knows, is whether or not the game's over, right? So we'll have a Boolean here, right? That's either true or false. It's just a yes or no, game's over or not here. Is game over, right? So to figure out if the game is over, we have one of two things could happen, right? Either somebody won, or it's a tie. Called a cat's game for some reason. I have no idea why they call it that. I kind of want to Google it now, but that's okay. We don't need to spend the time, right? So either somebody won or we tied. So we can do that, right? We like to take big problems and break them down into smaller problems. Let's do that. So we're going to return. This is, I don't know, has winner or is tied, right? We can have a has winner function. That'll be true, someone has won or not. And we can have an is tied function, whether or not it's tied or not, right? If either one of them is true, the game's over. If neither one of them is true, then there's still more game to play, right? So we can OR those together here. It says, oh, I don't have those functions. That's okay. Now, these are probably private functions, right? Because we have the is game over. If you want to make them public, it's not going to hurt anything, right? Just thinking about what we want to give to the person using my class, we want to make this as easy for them as possible. If you give them 3 options and they like accidentally loop off of as long as the game isn't tied, keep playing, they screwed up. So it might be better for us to assume people using our code are stupid. Which is what we should assume our users to be, right? Because users will do the weirdest stuff to our code. We say, hey, enter a number, and they type out the word 10. Nobody does that. Why would you do that and then crash my program, right? That sort of thing. So I think private is better for these. But again, if you want to make them public, it doesn't really matter here. But we'll make them private for now. So this is a Boolean is tied here. And this one's actually really easy. We know the game is tied if there is not a single empty space. Technically. It could also be someone could have won at that point here, but because we know we can check both, we're probably safe to just, if there's not a space, we can assume the game is probably tied. Is that fair? Might technically be wrong here. Maybe we might want to check if there's a winner, and if there's not a winner, then but again, it's fine here. Assuming there isn't a winner. What else is problem to check? Right, that's fine, right? This is just our code. It's our internal code we're helping with here anyway. So we're going to go through. So we'll say for, now this one here is a vector of char we'll call the row in the board, right, using our little enhanced for loop. So for every row in the board, here, let's go do that. And then for every char, I don't know what, space in the row, let's go look. If the space is equal to a space, oops, some parentheses here, sorry. If space is equal to a space, we're going to return false. Game over. Lowercase f false. There we go. We found an empty space. You cannot be tied. Right? Can't happen. There's an empty space. Okay? So we can quit immediately. If we've gone through every space in every row and we haven't returned false at the end of that, we can return true. We must be tied because we're not tied. Right? Okay? So that one's pretty quick. Just loop over. If you find a space, stop. Game over. Right? All right, the has winner is a little bit more complicated here. So Boolean has winner here. Really, this one now is 3 different pieces. Right? You can win by row, you can win by column, and you can win by diagonal. Right? Either diagonal here. So let's make a hard problem easier. Right? So we're going to return has winner by row, or has winner by column, or has winner, oops, parentheses here, has winner by diagonal. Right? It's that one or that one or that one. If any one of them is a winner, sure, we are a winner. Great. Right? We can break down into smaller problems, right? Anytime you can break it down into smaller steps, go for it. Maybe at some point we want to stop, right? But I think this is a fair one to break up here, right? Because otherwise it's going to just be 3 different pieces here anyway, right? So let's check by row first. So let's do a Boolean has winner by row. Okay, well this one now, for every row here, we're essentially copy pasting now. Now we don't want if the char is a space here, we're not checking that. So we're gonna go for every row in the board, and then for every space in that row. Well, really, we don't even need to look at every space in the row. What we want to look at then for every row is if my row at index 0 does not equal a space, right? Because if we're not a space, then I'm either an X or an O, right? And if I'm an X or an O, then do I match my neighbors? Right? So if I'm not a space and my row at index 0 is equal to the row at index 1, do I match the next column, right? And do I match the last column? Row at 0 equals row at 2, right? If I'm not a space and the first matches the second and the first matches the third, I'm either all 3 X's or all 3 O's. I don't care if it's X or O, right? It really doesn't matter at that point. I could, if we wanted to, return the X or return the O or be fancy here, but most people can look at the tic-tac-toe board and know who won, right? We're going to assume that level of intelligence from our people, which might be a stretch. Again, users are stupid, but that's okay. Right, so if that is true, then we can return true. Oops, return true. We found a winner. If we've looked at every row and didn't return true, we can return false. We didn't have a winner, right? No winner by row. That part makes sense? Right? Now, we get the same idea for columns here. So a column I'll just copy paste, but now it's not for every row in the board here, right? We want for every column index, as I want to check column 0 for row 0, row 1, and row 2. I want to check column 1 for row 0, row 1, and row 2. I want to check column 2 for row 0, row 1, and row 2, right? So it gets to be a little bit more awkward here, but what we can do is we can go by index, right? So we'll say for int column index is 0, column index is less than 3, column index plus plus. Now, you might be tempted to have I's and J's for indexes of rows and indexes of columns. Please don't do that. It drives me absolutely bonkers, right? Just for me, please don't. I have a really hard time telling the difference between an I and a J in code here. They look so similar, and when you've been looking at code for 8 hours a day, just staring at your screen, things start to get fuzzy and blurry, and despite how much coffee you drink, you still just get really confused. And it's just not worth confusing people when we can type 3 more letters here. And again, you never type this every time. You let the computer type it for you. So it's not like I have to type 6 characters or 9 characters every single time. Or 11, 6 plus 5, 11 characters every time. I type 2 letters and hit tab, right? It's not any slower here, and it's just way more readable. Is that okay? All right, glad, good. All right, so now we're gonna say, okay, if my board at row 0 at the column index is not a space, right? So always row 0 at the column index. So this will be row 0, column 0, row 0, column 1, row 0, column 2, as we go through our loop here, right? If that one is not a space, and my board row 0 at the column matches the board at row 1 at the column, right? Does this row for your given column match this row for the given column here, right? And does that row at 0, right? Row 0 at the given column match row 2 at the given column. So it's just a little longer here, but we're using the two-dimensional notation every time here for a given column index looping through 3 times. Again, we could probably even avoid the loop. If you just wanted to type it out 3 times, it's not too bad here. For the next thing we're going to do another game. It's much easier to use the loop, I promise, because there's a lot more possibilities with Connect 4 than there are for tic-tac-toe. Is that okay? All right, but now we have a winner by column. If we found a winner, great. If we went through all 3 columns and didn't find a winner, return false. No one won by column. Okay? The last one is has winner by diagonal. Now this one again is a little bit different here. So this is a Boolean, has winner by diagonal. Now, you could use loops. It would be fine. I'm not going to. When we go to Connect 4, you'll want to use a loop. But again, for our example, it's just easier not to here. So in either case, the center square has to not be a space, right? 1, 1. Because both diagonals run right through the center, right? So if we can look at 1, 1 first. So we can say, hey, if my board at 1, right? Row 1, column 1, does not equal a space. That's the initial condition here, right? And then, now, does this corner match the center, and does this corner match the other corner? Right? So that's 0, 0, 1, 1, and 2, 2. Row 0, column 0, row 1, column 1, row 2, column 2. Right? That's our downward diagonal. And we could break that up even further if you wanted. At that point, it gets maybe a little bit silly. It's probably nicer for Connect 4, but again, we'll get there later. So now board at 0, 0 is equal to board at 1, 1, 1, 1. Right? And again, I'm using the index notation on my vectors. You could use the .at notation if you wanted here. Both should work just fine. This one does give you the checking, doesn't it? Wow, I don't remember that now. C++ vector does square braces give bounds checking. I don't remember anymore. Let's see. Syntax is used when using the operator. It's undefined behavior, but we like the square brace notation. What? This is not telling me what I wanted it to do here. All right, now I'm feeling lazy. Okay, let's. Do you guys remember if it does or not? I don't remember at the moment off the top of my head.
You're saying if it checks?
If it gives you the exception for out of bounds checking with the square brace notation. I thought it did, but now I don't remember. All right, can we just do a vector of int here, numbers 1, 2, 3, and then see out numbers at 3. Line. Can we just run this one? Oh, shoot, I'm gonna have to. I think maybe I can just run this one. Why don't I remember this? Hey, okay, it does fail. Good. Yeah, it crashes on us. That's good. That's what we wanted. Index out of range. Right. For some reason, at one point, I thought only the at function would do it. But it's undefined, so I guess they can implement it however they want. So that was a fun rabbit trail. I'm sorry. Anyway, so does 0, 0 match 1, 1? And does board at 0, 0 match board at 2, 2? Right? That was our check. Did those 3 diagonals match here? Right? That one. Then we want this thing, right? Or the other thing, which gets to be a little bit awkward here, but that's okay, right? So does that diagonal match here? Or does my other diagonal match here? So for the other diagonal, it's not 0, 0, it's 0, 2, first row, last column, right? Does that one match the center? And then does first row, last column match the last row 0 column, first column, right? So 0, 2 is first row over here, 1, 1 is the center, and then 0, 2, top one over here, does it match row 2, column 0 down here, right? So it's a diagonal up, right? So if it's not a space and these ones match, or these ones match, we have a winner diagonally, right? That's a little long here. Maybe we'll bump that down one. Try and make this look a little bit cleaner if we can. Does that look a little bit cleaner? Oh goodness, what did I do? Now, at this point here, where's my parenthesis? I've got this one I started, that one here, this one here needs another parenthesis, and then we end the whole parenthesis here. Here we go. So if you do this and say, hey, return true, else return false, you've done a bad thing here, right? If the only thing you do is check to see if something's true, return true, don't bother with an if, just return it, right? Just say, hey, return that value, because you just said if it's true, return true. If it's false, return false. Like you've wasted some time here. Again, if you think it's more readable, fine, but I think this is relatively easy to get the point across here, right? We're returning this one and this thing or this thing. Either this diagonal is true or this diagonal is true, and the center is not this, right? Then we should have tic-tac-toe. Now, you might want them to not be able to mark if there's a winner or it's tied, right? We've got that option here, so we could add that in here. So we can say, hey, if has winner, I'm sorry, is game over, right? If the game is over, right, and they're trying to mark the board, how about we throw invalid argument exception, game is over. Maybe not an invalid argument, but that's okay. Again, I just prefer this because it's nice and easy, and I'm lazy. I don't want to have to go make a custom class for exceptions and do all that sorts of fancy things here. It's a little bit lazy, I apologize. But as we're throwing in exceptions, I feel good. So if the game's over, tell them, no, you can't play at all. Stop, right? If the game's not over, sure. Is it not empty? Great. Okay, let's go mark it. Change the next player's turn here. Okay? So essentially what we get then, over in our game here, we're going to include our tic-tac-toe. We can go make a tic-tac-toe. So I don't know, a tic-tac-toe game here. We go make our game. Great. And then I can start playing the game. While game.is over, well, not is over, right? We want to keep on playing our game here. Let's go print out the board. So we're going to see out game.display, right? Maybe need an extra end line. I think we ended with an end line anyway, but sure, we'll find out if we need an end line or not here. So we'll show the board, right? And then we'll say whose turn it is here. So we can see out game.get current player, apostrophe s's turn, and end line. There we go. And then we'll have probably an int for row and an int for column, right? If you want to put them on one line, great. I just don't like variables on one line. I don't know why. I just never got in the habit of it. So then we can see out, enter a row index and a column index to mark here, right? End line, and then we can see in row index, a row and column, right, at the same time. If it's this space this, it should work for us, right? Or this enter this, but I think both ways should work with our CN here. You seem be able to CN more than one variable at a time?
Back to back?
Yeah.
Yeah, it doesn't work, does it?
Should.
You should?
Should. I think so. Maybe I'm remembering wrong. We'll try it and see. We'll find out, right? And then we go mark it. So game.markBoard, given the row and the column here. Now, this may or may not crash, right? So here's now where we don't have the try block, because I know my game might raise an exception here. We're going to try this thing here, and then we're going to catch, what do we have, like an invalid argument exception? Invalid argument EX or something, and we can see out the EX dot what here if there's an error here. If not, great, we just keep on going. Eventually when the game's over, right, this loop stops and we just display one more time. Maybe we even see out, we say game over or something. Game over, right? And we stop. Hopefully this works. We'll try it and see, right? We'll find out. Uh-oh. Game over. Why do I have B's? How did I get a B in my output? What did I do? Board with a B? All right, well, let's find out. Let's put a breakpoint in here and debug. No worries. All right, we're going to go display. So we're going to look at what's happening here. So this is our this variable. We have a board. Oh, it's null. I never instantiated it here. Sorry. So we have to say my board is equal to a vector of type char parenthesis. Hopefully that ought to fix it here. Let's see. Now we should have a board. No? Really? I didn't do parentheses up here for tic-tac-toe game. Is that it? No? Just game? I don't know. All right, let's put a breakpoint in here. What did I do wrong? Let's find out. So we step into our code. It should call the constructor. Cool. Board equals the vector. Okay, now board is a value. Make a row, push back the row. Make a row, push back the row. Make a row, push back the row. Loop is done. Current player gets X. We're good to go. We get a row and column. Well, not okay, so checking if the game is over. If game is over. So we step into here. So we have, this is our board, size 3. Great if we have a winner, if we're tied. Here, right, we've got 3 spaces, right? Looks good. We've got 3 spaces, looks good. We got 3 spaces, that looks good. Here, so we'll step into. So it has winner, says we have a winner by row, winner by column. It has winner here, so we're going to step into our next code. So it has winner by row. Not true. Not true. Not true. Returning false. Good. That would return false. Step into the next one. Here's winner by column. Here. Not true. Not true. Not true. Returning false. Good. Step into our last one. Winner by diagonal. Step over that one. Oh, this one's returning true. Uh-oh. Did we do something wrong here? If it's not a space and... Oh, I missed a set of parentheses here. Goodness. Okay. So, you guys let me do a dumb thing. Come on, you got to catch me. When you and or together, there's an order of precedence. Remember which one goes first? Hopefully by knowing we have a bug here, you can pick up which one was happening first here, right? The and happened first. So I anded these together, which was false. But then I said, or do these ones match? And yeah, they match because they're all spaces, right? So I need one more set of parentheses here around the or to force this one to be or'd first. Then the whole thing anded with it's not a space, right? Because this is going to be true. Right? They're going to match when the board's empty because a space matches a space matches a space here. Right? Okay. Now let's give it a try. And I can take out my breakpoints, hopefully. Take out the breakpoint, continue. Hey, all right. Why do I still have B's, though? What's happening with that? What's wrong with my display? Why do I have B's? I forgot the display was broken. What's wrong with the display? Board... at and a space. How do I get a B character? Oh, I think I need to add these as strings here. Is this it? If I add it as a string. Remember how characters are stored as numeric values in their Unicode value? I think C++ was adding them together and giving me a numeric value. And saying, oh, yeah, space plus this character plus this character, adding a bunch of values together. And I think that gave me the B. So I think if I do strings here, it should be a little bit nicer. Oh, but now I have to do it 3 times. Uh-oh. Oh, and it doesn't like my string. What? Whoa, goodness. Plus string. Not like a string?
What commas?
No, because I want to concatenate. So do I need to be, how do I convert, C++ convert char to string? Not a pointer, I just want the char. Use string of S. String, ugh. That's really obnoxious here. Do I really have to do that? Unscoped. Yeah, as a character. So we say string of this. String of this? Is that? No, doesn't like string of that. All right, this was supposed to be the easy part too. Shoot. Let's see. It's not a pointer though. All right, maybe this one came out better. I don't want to use a string stream. No, that's obnoxious. 1 and C. What is 1? String assignment? String plus the C? Huh. All of that seems really annoying here. So, okay, so string 1 in this. Oh, it's telling it the size. Okay, so if I tell it what size it is, it's 1 character. That looks a little happier. And then plus that as a string, right? Goodness, stop being so helpful. Why did this one not have to get converted? I'm super confused here, friends, but that's okay. We'll do a bunch of conversions, then why not? I guess this is why it's bad to have a loop. Or not have the loop, because I have to do this 3 times now. Right? All right. Close enough, and I'll replace this one with that one, and I'll replace... No, too much. Just this line here. And just this line here. All right, and then we go to the next row. So row 1, row 2, row 1, row 2, row 1, row 2. All right, did we get them all? Hopefully we got them all. Let's try it again. Hey, all right, now it looks pretty. Okay. Whew. We're getting there. You guys want to play tic-tac-toe? I'll let you go first. If you beat me at tic-tac-toe, you get an automatic A in the class.
I'll play.
Go for it.
Okay.
Where are you going to go?
Start with X?
Yeah, X first.
Okay, top left.
So what row and column?
0, 0.
0, 0? Okay, so my turn. So if you go there, I think I need to go in the center. Is that right? Sounds right. 1, 1. Oh, come on, I didn't put my O in. What did it do? Okay, is my notation bad? We'll come back to the game. We'll fix it in a second. So my current player change must not have worked. Current player equals X if current player is O. Otherwise O? It should have changed it to O, right? Forget it here. I'll just go back to this one because this one ought to work here, right? Should change current player. Let's try it one more time. All right, so you went 0, 0. I went 1, 1. There we go. I don't know what was wrong with that ternary.
2, 2.
2, 2?
Yeah.
Okay, so you want to go for one of these to have 2 ways to win, so I need to force you to go somewhere else. So if I go up here, you'll have to go down here. So I'll go 0, 1, and I give it a go where to block me?
Yeah. 2, 1.
2, 1? Okay, so then I have to go block you. So I'll be at row 2, column 0. You have to go block me at row 0, column 2. I have to go block you at row 1, column 2, and then you get the last space available, which is 1, 0. Game over. You didn't win, sorry.
Doesn't count as a win?
Did you beat me? Did you get a 3 in a row?
No, it's a tie.
No. My kids will never play with me anymore. My wife says I should let them win, and I refuse to. And she thinks it's mean to like play with the 6-year-old and tic-tac-toe and never let her win. But that's real life, right? Sometimes you just don't win at life. Now she says maybe the 6-year-old isn't ready for that lesson, and I should let them win sometimes, but I don't know. No, you can never lose at tic-tac-toe if you know what you're doing. That's fine. Connect 4 is a different story, though. If you know what you're doing, you will always win as the first player in Connect 4, guaranteed. It's a solved game, which makes it a whole lot less fun to play somebody at Connect 4 if they know what they're doing. All right, we okay so far? All right, 2-dimensional rows and columns, right? So you can imagine it like here's the row, here's your column. They're not actually stored like that, but it helps us visualize it here, right? So if we had 3 dimensions, right, we'd have rows, we'd have columns, and we'd have like height or the layers in between. That gets to be lots of fun. At one point, you used to do like a 3D maze solver in one of the algorithms classes for fun. That just hurts my head at this point here, and it does not sound like a very interesting puzzle. I suppose it might be, but that's okay. So 2D rows and columns. We used vectors. Again, I just like vectors. I like having the safety check where it crashes if you give it a bad index. Right? You could still use arrays and just do it by hand. Nothing wrong with that. It would work for you, but you have to be more careful to make sure you're checking all your bounds here. Like for us, we just said, hey, I already know it's going to check for valid. I don't have to deal with it. If you forget to do that, you could get garbage values, and that screws all sorts of things up here, right? So anytime we're dealing with arrays and vectors, you have to be very careful with your bounds, because if you do the wrong thing, bad stuff happens. And we saw that with our dynamic arrays too. If you try and read the next block of memory here, it lets you read it sometimes. It doesn't automatically crash on you, and you just read garbage. And if you're reading garbage values and putting that into your program, bad stuff happens. So there's a relatively common security vulnerability. It's called a buffer overflow attack that takes advantage of this sort of thing here. It's not exactly this, but in this theme of we're reading stuff in bad places or writing stuff in bad places here, when you can get something written in memory in a bad spot and make someone read it, you have a security vulnerability, right? It's actually kind of amusing to me here. Is it the federal nation to not use C++? See if we can find this one here. Yeah. This was in 2024. They said, hey, maybe people stop using C and C++ because bad stuff like this happens and people introduce vulnerabilities if they're not being careful here. I thought it was kind of amusing here. That's all. Maybe that's a little awkward to joke about or laugh at, but sure. Yeah.
How can you counter that?
By being very careful. So every time you're dealing with indexes and arrays, you have to check it. Like the idea is it's like a zero trust. I think is the technical term our security friends use, is never trust your input. Always go and validate, yes, this is good, before you do anything with it. So it adds some additional work every single time. It's like secure programming, making sure we're verifying everything first. Because it's really easy to be like, oh yeah, the user probably knows 0, 1, and 2. They're not going to type in 1, 2, and 3 and give me a 3 with an index out of bounds. And then someone comes along and like, what happens if I put in the 3? Does it do bad things? And can I make a hole in your program, essentially? So yeah, just being extra careful with that, managing your memory very specifically and very carefully gets to be a challenge. Right? When we looked at using dynamic memory and allocating new memory on the heap, if we don't delete it, bad stuff can happen. We run into all sorts of fun things, having to deal manually with memory management. That's why the idea was, hey, why don't you use a memory-safe programming language, something that takes care of that for you here, which is nice. And I actually prefer those sorts of languages, but that's okay. It's not too big of a deal. We don't do anything super crazy at this level where we're going to run into the issue, but weird stuff can happen. So yeah, I just thought it was funny, like, maybe don't do that. That whole C++ thing, that everything's built on, it's overrated. Okay, so arrays and vectors. Let's double check the zybooks here, see where we're at, see if we missed anything here. So we've got vectors iterating through, so iterating through them can be lots of fun. Going back and popping back, right? Removing items off your vector is really fun. We can maybe look at that. You can resize your vectors, right? Which is nice. You can have lots of vectors, looping to compare, swapping, arrays versus vectors, two-dimensional arrays. Character arrays and C strings, I hate these things. In C, strings didn't really exist. What they had was an array of characters, and they always had a null terminator at the end here. It was like a special character that said, hey, my string is done, stop looking for more characters. Which is really awkward because if you didn't include that, when you go try and read a string, it just keeps on reading and reads and reads and reads. So like, I didn't find your null terminator, where's the end of the string here? And then it keeps reading into bad locations in memory. So all sorts of ugly stuff in C when you get that sort of thing here. Like, oh, hey, now there's something bad, right? Because we didn't read this. There's I have to find the comic for you about it here. It's really funny. I thought it was really funny. Maybe you won't. But yeah, so dealing with strings is really obnoxious. Converting between the two is annoying. But this sort of idea, that's why there was that constructor that took a pointer to a character array. If we're dealing with C strings, you can convert it to a regular string or a C++ string pretty quickly as we go. So that was good. C types, sure. The C string library. If you're dealing with C strings, you can do all sorts of things with the C string library. You can copy strings, you can concatenate strings together, those sorts of things. Sure. I hope you never have to touch them. Honestly, they're just a pain in the butt. So if you do, go look them up. It's just one extra step. You have to do one more careful thing when you're dealing with C strings because they're treated very special. That's all with that one. All right. Yeah, so for Thursday, we'll spend more time playing with our vectors, using some of the other vector objects here. Navigating around vectors using the iterator is kind of fun, using our vectors that way. I don't have too much more today. Did everything make sense with the project and the video I posted for that? I call it the rule of three. That's what the Zybook calls it here. Like if we are using dynamic memory and we have a destructor, we also then need to deal with copy assignment operators, or I'm sorry, copy constructors and copy assignment operators. We need to make sure we're dealing properly, making those copies if we're using dynamic memory, so we don't end up with two objects both pointed at the same location in memory, right? Because then we don't actually have a copy, you have a shallow copy. And then if you have a shallow copy, someone else changes theirs, they've just changed yours. And now you're sad because it's not a real copy. Right? So we'll be using those in the assignment for the project, right? So we make our class here. Oh, I didn't have the rubric. Shoot, I'm sorry. I think, how did I break it up here? It wasn't a whole lot here. I think it was like 2 points for fighting pet, and then points for destructor, points for copy constructor, points for copy assignment operator. I'll add that in for you. Just kind of break it out because this was 10 points here. So we have 10. Well, I can go at it here, right? So this is project 0 here. These are all going to be 1 point each here. This will be trainer class, private attributes. Right, you've got all your private attributes, right? You point for that here. And then trainer class constructor, and then a trainer class copy constructor, a trainer class. I'm going to copy that. There we go. The copy assignment operator, and then our destructor. Here, all those are 1 each, right? And then we had our methods here. So this is private attributes and get methods. Right, so you should be able to get those things. We're not going and setting any of those. Then we'll have add experience points. Trainer class, add experience points. And then we had add fighting pets. Trainer class, add fighting pet. And then we had the add more fighting pet storage. There we go, trainer class. Add more fighting pet storage. I didn't put it all in one word, sorry, for that one. And then the fighting pet class. Fighting pet class, add attributes, public gets. Now, these ones, if you want to set them, fine. If you don't think you should be setting it, that's okay. I think it's fine to just have gets and sets. This one can just be really boring. Here, we don't really need to put a whole lot of constraints around this one here. You know, at some point you might limit the number between 1 and, what do we have, like 823, some, or 12, is it 1100? I forget now. We keep adding more Pokemon. I mean, fighting pets here. Totally not ripped off of anything here. Sure. So if you wanted to add some constraints, we could. We don't need to at that point. So, oh, those are 1 point each. So that should add up to the 10. Did I not do it right? Oh, that's only 9. Okay, what did I miss here? Class, attributes, destructor, copy assignment operator, methods. The add more storage, that should be worth 2 points here, right? Because that's a little bit trickier, right? Where we're going through and copying from the old storage to the new storage, and then deallocating the old memory and assigning, right? That one's got a little bit of extra bit to it there. So, all right, so there's a rubric. There's the 10 points for that one here. So essentially piece by piece by piece. If you get to next week and you don't have it all done, that happens. It's okay. I mean, hopefully you get it all done. I love when everyone gets 100% on these, right? It's all doable. But if not, focus on here's 1 point, here's 1 point, here's 1 point. Do the things you can for points, and give me a solid try for things you don't know how to do, and I can at least give you partial points for trying, right? hey, I don't actually know how to do this, but I'll make one, it just won't function properly, I can give you partial points, right? That make sense? Okay, so we'll work off of that. Again, this one is due, is that the 4th, so next week, 3:30 p.m. So we'll have a little bit of time next week. I don't think we'll take up the whole time talking about vectors and some of the other fun things we can do with vectors. So we'll have a little bit of extra time to work on that as well. If you got questions, let me know. If not, we got lab tonight, so we'll do some more 2D vector stuff for labs. We'll have a little bit of fun making Connect 4. I think that's always lots of fun. We can go from there, okay? All right, awesome. Well, hopefully you can go find some food somewhere. I don't know if anything's hot anymore, but again, if you guys complain about that, they might listen. They don't care when I complain about it. So please let people know. All right, and thank you so much.